All right. Good evening, everybody. Good evening, one and all.
Good evening, sir.
Bless up, Dominic. Good evening, everybody.
Good evening, sir.
We're back at it again. Third day in a row. Working hard.
Good evening, sir.
Evening. Brandon, big up yourself.
Good evening, sir.
Evening, Latisha. All right, so put in the work, people. Put in the work. Final touch-ups. All these topics that have flew over your head. Good evening, Simonia. We're going to be working assiduously at them. All right. So tonight, night number 1, we did a lot as it relates to functions and relations. That video is out and ready for you to watch in your own free time. Last night we did vectors and matrices, covered a lot of stuff, especially vectors, which is quite a bit tricky for a lot of people. And tonight we're going to take on another tricky one, circle theorem. So we're going to be checking on circle theorem tonight, and alongside circle theorem will be bearings, sine rule and cosine rule. So we're going to be taking on that. And let's have some fun tonight. All right, so saddle up. We're going to be here until 9:30. So get ready. All right, we have 41 persons present. Amoy, Alice, Saunders as usual, Dominic, Safani. Yes, man, clap. I see you, man. I see you. Danica, Nathaniel, first time. Brown, Abigail, Jaden, Geneva, Miss Gentles, Kadia, Kalu, Bennett, Booth, the usual suspects. Miss Paddyfoot, nice to meet you. I'll start call you the echo name we have on TikTok, you know. Kaya,
Yeah,
been here?
please.
All right.
Or Trina.
Trina is fine. Kaya, what go on?
Yeah.
You been here?
Yes, sir, from yesterday.
You never come Monday?
When me did see the message, me didn't kind of too late, so me didn't forward.
All right, cool. Wait about. All right. Okay. All you guys are here. Misuno. Big up on yourself. We get into it now. Javar. Yeah, man. Yeah, Javar. Me see you, my boss. Me see you, G. Oh, we have Oriana first time here. Oriana, this is the first time you come in?
Yes, sir.
Okay. Where were you?
Sir, I was busy yesterday and Monday. I was preparing for exam.
Okay, all right. Cool. And Jay there. Miss Johnson. Is you ready? Bomb down some much that night, yeah?
Yes, sir. But may I go take a little break at 7 o'clock and come back on about 7:30 somewhere there.
Let me know when you're leaving.
Yeah, man, no problem. Cool.
All right, guys. As you can see on screen here, there's Zoom or freeze my phone, you know. I'll get a new phone. All right, guys. As you can see here on screen, we're going to be looking at question number 10, measurement, geometry, and trigonometry. So we're going to be talking about angles and sine rule and cosine rule and bearings and, you know. So the geometry has to do with the circle theorem. The trigonometry has to do with the triangle. And measurement you might see a little bit of them asking to find the area or the perimeter of something. So official welcome to everybody. Let's kick off this class with a bang. Let's go. All right, and thank you all for the Happy Teachers Day today. I greatly appreciate it. I almost bombed on the wall on my phone, but respect. Thank you very much. I appreciate it. It's good to know my hard work is recognized. Thank you. All right, let's get into it. Measurement, geometry, and trigonometry. All right, ready. No, remember, before we get into it, people, circle theorem is mandatory. It will come on the exam, guaranteed. I don't recommend that you leave it out. It's worth 6 points. Try to see if you can steal at least 1 3 or 1 4 out of the 6 points. All right, and then it combines itself with sine rule, cosine rule, and all that kind of stuff. All right, so there are 13 theorems. Sorry, there are 9 theorems that we're going to be playing around with. Please pay very close attention to the colors that I'm using to highlight different sections of the circle. Right? Any theorem we are here for the first time, write it down. Anything we saw new, write it down. Listen attentively so you can learn from the other students who have somewhat of a better grasp at the topic than you. Okay? Let's kick it off then. The diagram below, not drawn to scale. The diagram below, not drawn to scale, shows a circle with center O. And we can obviously see that the center is right here.
And what time I say I come back tomorrow?
Buckingham, you need to control your microphone every time you do this.
Please. Yeah. Please come here.
Carrie. Guys, please control your microphones, please. I'm going to let out no personal business from the media. You know? All right, so as you can see here, the diagram below, not drawn to scale, shows a circle with center O, which you can clearly see marked by the letter O on the diagram. Now, the points A, B, C, and D are on the circumference of a circle. I want to highlight this. Now, this is a statement that seems to be trending when it comes to CXC circle theorem questions. Whenever they tell you, let me see if I can use a different color. Give me a second, guys. I'm going to get them ready. Hold on. So whenever them tell you, okay, hold on, guys. Opacity, size. Okay. So whenever them tell you, right, that the points something is on the circumference of the circle, I'm going to tell you what they're trying to tell you. I'm going to tell you what you need to pay attention to. You need to pay attention to the fact that this shape is what is called a quadrilateral. But it has a very special name. It's not just a quadrilateral. It has a special name. Can anyone of my students tell me what that special name is?
A cyclic quadrilateral.
Very good. It is called a cyclic quadrilateral. So you're learning that for the first time, jot it down. So cyclic quadrilateral. All right. So look at the statement, that CSEC gives you. Whenever them tell you, say, the points blah, 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 blah are on the circumference of a circle, chances are, and when we say chances, I mean a big chance, that there is a cyclic quadrilateral present there. All right, so let's write that down. Cyclic quadrilateral. Now, the next thing now, after recognizing the cyclic, you need to know what about the cyclic do you need to know? What about the cyclic is it that is so important? Why you have to pay attention to that? Now, ladies and gentlemen, under cyclic quadrilateral, there are 2 rules that you need to be familiar with. I'm only going to expose you to the rule that is associated with this particular question. So under a cyclic quadrilateral, right, the rule that you need to recall is that opposite angles sums to 180. Opposite angles sums to 180. Sums to 180 degrees. All right. Now, please bear in mind that when I'm teaching you this question, if I wanted to just take up the question and just throw the answers at you, I could have done that. I can work this question in 5 minutes or less. But I'm trying to teach you how not to fear this question, the things to look out for, and where the clues lie. So every question will be explained in details. So basically, I do the question and I teach at the same time. All right? So pay close attention to what I go on. Now watch this now. Boom. You see that red thing that I've just highlighted in the diagram. What that means for me now, people, is that you see this angle up here. Hold on. You see this angle right up here, and this one down here, them add up to 180. Whatever it be. We just want to say add up to 180. So this one down here, and that one up there add up to 180. All right? Those two angles add up to 180. We don't want to give them a letter. Just know that those two blue lines add up to 180. Not only that, this one over here, let me grab a different color. This one over here and this one over here also adds up to 180. So that information is going to be key when it comes to answering the questions further down. Knowing which angles add up to 180 is going to be key. A lot of students know that angles on a straight line measure 180, but many persons did not know that opposite angles in a quadrilateral that is inscribed in a circle adds up to 180 as well. So please bear that in mind when we come forward. All right, next thing now. EAF and EDG are tangents. Let me highlight that for you again. That's a key information for you. EAF, hold on. EAF and EDG are tangents to the what? To the circle at A and D respectively. All right. So this now means two things. Two things this mean now. If you have two tangents, right? Let me just use a yellow marker for this one. If you have two tangents, right? This is tangent number 1. And this is tangent number 2. And they are drawn to the same circle. You know what that means? That those two tangents are of equal length. Because they are being drawn from the same point, which is at E right here, so. And they are being drawn to the same circle, we can safely say that these two sides down here are going to be equal. Those two sides are equal. Now, what happens when we have two equal sides inside of a triangle? It forms a very special triangle. What's the name of that triangle?
Isosceles triangle.
It forms an isosceles triangle, not true? So I'm going to grab one little highlighter here now. I'm going to highlight the isosceles triangle for you. So the isosceles triangle is going to be right in here, so. That's your isosceles triangle that you're looking at right there. Okay? So that blue section is your isosceles triangle. And because the two sides of the isosceles triangle are equal, what can we say again now? That the angles down here, hold on. That the angles down here all right, so what can we say here? That the angles down here, this one, this red one right here, and this angle down here, so they are equal. So look at the colors that I'm using. Anytime you see me use two same color, it means that the two colors then means that they are equal or they add up to 180. So pay close attention. So these two angles down here are equal. So far on this diagram, I've only read the first two sentences. I've only read the first two sentences and already look how pretty my diagram be. All right. So when you have two tangents drawn to a circle, those two tangents should be equal. Now, another thing that I want to highlight. Oh, do you want me to write that down? No, you can write it down, guys. So two tangents drawn to a circle will form an isosceles triangle. Whether obviously it's going to be on the outside because tangents are on the outside. So if you have two tangents drawn to the same circle, there is an isosceles triangle somewhere there. Find it. And if you have an isosceles triangle, that means you have two angles equal. And we know that angles in a triangle measure 180. All right. Another information that you need to pay close attention to. Every question I'm going to break down circle theorem in detail. Okay. So another thing that I want you to pay attention to when it comes to seeing a tangent. Anytime there's a tangent, there's a high probability that there is a 90-degree angle present. Now watch this now. Watch carefully now. Look at this. From O straight down towards the yellow tangent. That line right there is a radius. And that radius, if you have a radius that is drawn perpendicular to a tangent, then we can safely say that the angle right where the radius and the tangent is measures 90 degrees exactly. All right, so this is a 90, and we also know so the other side over here so has to also be 90 degrees as well. All right, because angles that are pointing a straight line measure 180. So look where the 90 is. You see them? See, 90 is on the left, 90 is on the right. And that is all because of that green line coming straight down to meet that yellow line. That forms a 90-degree angle right there. And not only this alone it forms, you know. Look, it also forms over here as well. Boom. Because this green line again now, it meets another yellow tangent now. So once again, over here, so. Whoops, sorry. So over here, so. Over here, oops, sorry, guys. So over here, so. Is 90. And also over here, so. Is 90 as well. All right. Good. So that there, so, is giving us a lot of information. So now that we have read everything at the top, and we have identified different sections now, we have everything we need now. We just have to just answer the question that you're asking us and give a reason why we say it is. All right. Now, one last thing before we move on. Do you notice those two green lines that are coming from the center? Those two radii, pardon me, are equal. So once more, these two sides are also what? Equal. Again, let me grab a different color here. So these two sides here, this side here. So this side here is equal to that side here. Once you have all those information, right now I've saturated you with so much rules that finding the answers now are gonna be easy. Look at this now. And they gave you some special angles. They said 114 and 18, and we can see those angles. Ready? First question says, calculate, giving reasons, right? So it could be a reason, or it could be reasons for each step. So every time you write down something, you have to tell him where you get it from, how you get that. So giving reasons for each step of your answer, the measure of angle ACD. Now, even without me telling you, do you see them have something right atop the CD or so? They're trying to tell you that the position of this angle that they want you to find is located at the letter C. So let's go back to our diagram. Where is C? C, the up there, so we have to touch A, D, C. A, C, D. So A is here. May I clean, guys, may I clean up my diagram? Know that we can now? Can I clean up my diagram?
Yes, sir.
Everybody? Where's the chat? I'm not seeing anybody in the chat. Can I clean up my diagram?
Yes, sir.
All right, good. So now that I clean up my diagram now, right? Because if I don't clean it up, it's going to be messy. So now that I clean up my diagram now, they want us to find the angle. What now? Let me show you how you identify this thing now. They want you to find the angle A all the way to C, come down to D. So which angle you see them want you find? The angle right in here, so that angle they want you to find. ACD. So the question now is, how do you find that angle? Now there's a theorem, right? There's a theorem called the twice the angle theorem, right? We call it the central angle theorem, right? Now look at this, guys. Watch the markings carefully. An angle is created at the center, right, by the line AD. Look at it. Hold on. Look at this now, guys. Hold on. Watch this now. So look at the line AD here. Boom. That's the line AD, right? And AD creates an angle at the center. Bob, that's all. So it creates an angle at the center here. And it creates an angle right here at the center, right? That angle right there is 114. But look at the same red line again. That same red line creates another angle at the circumference right there. So what does that mean for us? That simply means that the angle that is at the center of the circle is twice the angle that is at the circumference. That's a lot of writing for a lot of people. That's a lot of writing. That's a lot for a lot of persons to remember. So what do we do to replace all that excessive talking? We simply say central angle theorem. All right? So what we're saying about this now is that, let me just grab my information here. We're going to say angle ACD is equal to 114 divided by 2. And the reason for that is central angle theorem. Central angle theorem. That is how you find the angle right there. So that angle works out nicely to be 57 degrees. Sir, why did you divide it by 2? As it states that the angle at the center of the circle, it is twice as big as the one that is at the circumference. Listen again. The angle that is at the center of the circle, it is twice as large as the one that is at the circumference created by the same chord. Therefore, the one at the circumference must be half the size of the one at the center of the circle. And that is how you find angle C. Everybody clear on that? Everybody's clear on that?
Yes, sir.
Yes, sir.
Lovely, lovely. Like I said, if this not, remember me have a detailed video on this. So if you guys would love to go back and watch how it's explained, you're free. It's over there. It's free. So this angle here is 57 degrees. Every time you find one angle and you're convinced and you confirm that that's the angle, you place it into your diagram. All right, please place into your diagram. Samara, please put your mic on mute. Thank you. Thank you very much. Ellis, your mic is also on mute. All right, thank you. Lovely. So that angle is 57 degrees. Moving right along.
Okay.
Yes.
It's not the angles in the same segment theorem because angle AOD is not at the circumference also.
Pardon me?
What is it? It's not the angle in the same segment theorem because angle AOD is not at the circumference with ACD.
That is correct. That is correct.
Okay.
They both have to be at the circumference for you to use that particular theorem. How do I know it's bigger? What do you mean, how do I know it's bigger? That's the rule, Latisha. The rule states that it has been proven long before you and I were even born, right? That the angle that is in the center is twice as big. It's a theorem. So it has already been proven. You just work with it. Once you spot it, you just work with it.
Sir, question.
Okay.
What's the difference between angle C and angle B, considering that the line that runs, chord that runs from A to B starts the same place as one that runs from A to C?
All right, watch this. Very good question. Look, you see, from AD, right? AD makes an angle at the what? Circumference, not sure. But AD doesn't make an angle at B. There's a line running from A to B, but the line from A to D doesn't exist. From D to B doesn't exist.
I want to draw it like that, so that it's going to become the Z theory something.
No. You have to see one arrow on the lines to assume that there's a Z.
Oh.
Or if it look like one Z, it's not a Z. You have to have evidence to say that.
Okay.
All right, good. All right, lovely. Good question, Sam. All right, answer that question. We're going on a road. Central angle theorem. I don't know what happened with that robot. AED. AED. So the angle is at E. AED. So let's use a marker here. AED. So that means you're looking for the angle down here. So, but remember, so we established from day one, you know, that triangle down here is what? isosceles, not true? Not true. It is isosceles, not true? So this triangle here is isosceles. Talk to me, guys. Agreed?
Yes, sir.
And then guess what happened now? This one up here is also isosceles. Not true? So you have two isosceles triangle joined together. Guess what kind of quadrilateral it makes? You have two isosceles triangle joined on together. What kind of quadrilateral does it create? You already tell you from earlier on, you know.
Cyclic.
Yes, man, it is a cyclic. It's just that part of the cyclic is outside. So this shape right here, is a cyclic quadrilateral. Now, what was the rule that I gave you up here about a cyclic quadrilateral?
Opposite angles add up to
Opposite
180.
angles.
So opposite angles add up to 180. So do you realize that we have the angle up here, which is 100 and what? 40, not true? So therefore, the angle that is directly in front of it is the angle that we're looking for. So what can be our solution then? Our solution for AED is that AED is equal to 180 minus 114, which is therefore equal to 50.
66.
66 degrees. 66 degrees. And what's the reason for that? Opposite angles in a cyclic quad are supplementary. Another word for adding up to 180. Write it or you want to write it. So opposite angles of a cyclic quadrilateral are supplementary. So come again, look at the diagram. We have a isosceles triangle at the bottom. That's because of the tangents. And we have an isosceles triangle on the inside, which basically is formed by the radius or the radii. And because the two of them join onto each other, it is going to form what I called an external cyclic quadrilateral, where part of the cyclic is on the outside and the other part is on the inside. Okay, so that is how I got the angle AED. Please make a note of these information. Take some picture in your mind. So if you go on the exam next week, Tuesday, and you see that something here, don't bother think twice. Just get to work. Just get to work. You know what time of day it is already. All right. So I'm taking out these mess up stuff. I'm gonna put on my actual information. So this angle right here is 66 degrees. All right. Every time you guys find an angle, please insert it on the diagram. It's going to give the diagram more life. All right. If you don't put the angles on the diagram, the same way how the diagram look when you just start it, a set gonna look when you're done at the end. You're gonna have to be searching through your calculations that you've done already to get answers. That's too much work. If you just look at the diagram and see what you want, life is easy. Okay, beautiful. That's it. All right, next one says OAC. So the angle is at A. OAC, let me use my marker and show you where OAC is. So OAC. OAC. So we're looking for that angle. You see the angle we're looking for? And if you don't see it, I'm going to highlight it for you. So OAC, we're looking for this angle right here. Look a piece of angle right in there. So this we look for right here. So this piece of angle right in here. So that's what we're looking for. OAC. That's the angle that we're looking for. Now, obviously, there's no geometric rule to find that. So you're going to have to find some reasonings that will lead you to that. Not true? Now, watch your style now. Watch this now. We know from onset that this thing here is a what? Isosceles triangle. Do we agree? I want to see people in the chat. I work with me now. Do we agree? We agree from earlier on, so that is an isosceles triangle, right? Or there are some persons in the chat waiting to enter? Hold on. Nobody's in the chat waiting to enter. All right. Back to regular programming. That this triangle right in the center here is an isosceles triangle. Not true? Geneva say yes. Okay. Everybody agree?
Yes, sir.
Good. And with an isosceles triangle, we know say them two sides here equal. So this side equal to that side. But because those two sides are equal, it also means that these two angles right here are also what? Equal. Please pay attention to the angle that we are trying to find. But I lose track, you know. So remember, I said the angle we are trying to find, you know. But we have to find something else to help us find that. So now, because we know that these two angles right here are equal, I will not say one of the angle 114. The first step to answering this question is to say that angle, we're going to give this angle a name, this one right here. We're going to give that angle a name. We're going to call it OAD. So angle OAD is equal to 180 minus 114 divided by 2. And when we say 180 minus 114, we had already gotten that the answer is 66. So when we divide that by 2 now, we're going to end up with an angle of what? 33. So therefore, this angle right here, I'm going to use my blue marker now to identify it. This angle right in here is what? 33 degrees. And the one over here, which is inclusive of what we want, is also 33 degrees as well. Not true? All right. Now, how do we find that little piece of angle in there now? Let me see here. All right. So how we're going to find it now? There's a rule, right? There's one of the theorems known as the chord theorem. It's the last theorem. I'm not sure if you guys have your books on you, or you can scroll back to the theorem that says, what's the theorem now? Let me clean up my diagram for a second. So there's a theorem now that says, watch now, ready? There's a theorem that says the angle that is between a tangent and a chord. So the angle that is between the tangent and the chord, let me identify the tangent for you again. So the angle that is between the tangent, that's the tangent, DG is the tangent, and the chord right here, that's the chord. That angle that forms between that tangent and that chord is exactly equal to the angle that the chord makes at the circumference down here. So that angle of 18 degrees in this corner right here, that angle of 18 degrees is exactly equal to that little piece with the down here, so right so. Down this are 18. Right in another little kucha this. This is 18 degrees right here. In this are 18 degrees. Right in here says 18 degrees. But remember, we just calculate, not true, and say that entire angle was what? 33 what? Degrees, right? We already calculated that by taking the 114 from 180 and divided by 2. We got all of that angle there to be 33. But because of that last theorem there that we got the 18, we can say that this angle right in here so now is 33 minus 18. Because the 18 is inside of the 33. So that angle, as Richardson say, would be 15 degrees. But let's put it on paper here. So we found the 33, right? Now the next reason what we have to write is write a reason for how we got this 18 here. So that 18 there is going to be angle CAD. Angle CAD. All right. So angle CAD. So angle CAD is equal to 18 degrees. How we get that? The angle between the angle between a tangent, and a chord is equal to the angle at the circumference. Maybe I have to go find one nice way to summarize that, but that's the actual statement that is in the book. So let me reiterate that for you, because my handwriting is so bad. The angle between a tangent, this thing right here, where you see me write that looks so atrocious, is a tangent. So the angle between the tangent and a chord, as demonstrated on the diagram here, the angle between the tangent and the chord, that 18 degrees here, the angle between the tangent and a chord is exactly equal to the angle that is formed by that same chord at the circumference right down there. That angle right there, so it's 18. And because of the previous reasoning that we had, that gave us the 33 there, we can therefore conclude that angle OAC is equal to 33 minus 15. Therefore, 33 minus 18, and that's equal to 15 degrees. All right? So that's the reasoning that is required for this question. Please bear in mind, this question is from 2000 backwards when they do this. I don't remember if it's 2010. But we're working the tough questions then. We're not running away from them. Sir, can you repeat the chord rule? Simona Chambers. Oh, the chord rule? See it here. Angle between a tangent and a chord. It is theorem number 9, I think it is Geneva. Theorem number 9. So the angle between the tangent and the chord is equal to the angle at the circumference made by the chord. It's equal to the angle made at the circumference by the chord. Okay, so that angle is 15 degrees right there. All right, good. Okay, so that is how you would find that thing there. All right, and then the last one here, angle ABC. Angle ABC. Oh, let me clean up my diagram and put on back the correct measurements that I need to see. All right, so I'm just put on the measurements then when me calculate, right? So I know that this angle right here is 33. I know that all of this angle right here is also 33. And that this angle in here says 18 degrees. And I know the one up here that I'm asking for is 15 degrees. All right, and I know the one up here is going to be 66 degrees as well. All right, so maybe some of you guys might find another way, a cute, cheeky little way to do that, so it's entirely up to you, right? If you see another way where you could find it, no problem. No problem at all. No problem at all. All right, cool. Oh, sorry, I found an angle down here. This angle was 66. 66 degrees. Yes, question.
Is your angle NCD 66?
And what did you say? Oh, 57. Sorry, that would say 57. Thank you very much. All right, cool. All right, so what them someone's find now? The angle what? ABC, angle ABC. Okay, let's go back to the diagram here. ABC.
So I think it's 66, not 56.
I'm not 56, I'm right. 57, I'm right.
Okay.
All right. All right, so now A, B, C, them must find A, B, C, the angle up here. But from the onset, remember in our earlier discussion, we were putting up the diagram, and we had said that this thing right here is a cyclic again, and opposite angles of a cyclic is what? Equal. That what did say? Sorry, not equal, but adds up to 180. So whatever this angle be, whatever that be, it must be 180 with that one. It must be 180 with that one, So therefore now, by cleaning up this diagram now, let us look at what exactly we need to find to get away. If we can find this other portion, if we can find this other portion of the angle right here, we would end up with all of this. And if we end up with all of this, we automatically can find that because they both add up to 180. Not true? All right. So anybody can suggest how would I find this portion of the angle?
Sir, you'd use the theorem, the point at which a tangent meets a radius is 90 degrees.
You could use that. That's brilliant, actually. I never ever see that. That's very good. You could
Or
actually
add up the next one.
Sam, hold on. I'm gonna make you talk, Sam. Hold on. Let me help her first. So she was saying, that's a good one. I never see that one. Honestly, I didn't see that one. Sam, I'm gonna come to you next. Give me a minute. All right. So she was whoever spoke a while ago, because I didn't catch the voice. That's a good. So she's saying that she could use the tangent and the radius meeting at 90. And because you already have 18, you could simply say that the angle right there is equal to 90 minus 18. Right? And that angle would be what? 72 degrees.
Yes, sir.
And then what is your reason? Oh, that Simona Chambers that just spoke. Alright, so that the reason for that now would be what? Radius. Sorry, let me write that better. So the reason for that would be that radius is perpendicular to tangent. All right. And then now you would have to now that you get that to be 72, what would be your conclusion now? That angle ABC is equal to 180 minus the 72 where you just find. And that's equal to 108 degrees. And what would be your reason for this? You'd have to see opposite angles of a cyclic quad are supplementary. That would be your reason for that. Okay? So that would be, if you took that route, then this would be your reasoning for that. Sam, you were saying earlier, love.
Sir,
Yes.
that right? You sure that right?
If it's right.
Sorry, why you never add back the 33 to the 72?
No.
Aren't you using the whole of the
Yeah, for real. So the 72. Okay. Right. So let me just add this on. Thank you, Sim.
Okay.
So I forget that part. So you have to add on right here. So now. Good observation. Samara. So the 72, you'd have to add on the what? 33 to it. All right. So then we're going to put that now on bracket. 72 plus 33, that's what? 105. So therefore, that would be 180. Let me just erase this here. So this would be what? 180. That would be. So that would be 180. Give me a second, guys. Hold on. So that's 180 minus 105. So 72 plus 33 is 105. And 105 from 180, that angle would be 75 degrees up there. This angle would be 75 degrees. All right, so Sam, let the class know now the other method that you saw to find that angle there.
So I'm going to remember how did I look at the time.
Let me help you, come this way. That's the first thing I saw, Sam.
The one, because I think when I use it, the triangle inside first,
Mm-hmm.
and
Yeah.
then the difference from the triangle.
Right. So you would have been saying this then. You'd have been saying this that right, so this here, right? This here. The one there.
Yes, sir, that's the one.
So you'd just add the what? What would you use? The 33 or the 18? Let me hear this.
You know,
Mm-hmm.
good question, because I was looking at it and I was
But
trying to
look
figure
at
out
it.
based on how it's written. The 18 look like it cover everything. But
Mm-hmm. Look
the
carefully.
33
Cover
have to be
everything, right?
33. So the 33, the 57, I'd have to add those and
So
subtract it from the one.
look at your triangle, Sam. Look at the triangle that I highlighted in black. The 33 go outside of the black triangle.
So the 18 and the one inside.
Right. Good. So if that's the route you're going to use, you'd have to say the missing angle right here, which is the one that we're looking for, this one right here, that angle right there, so that one there, you could say that that angle is actually going to be 180 minus 18 plus 57, 180 minus 18 plus 57 plus 33.
Yeah, that sounds like it.
Mm-hmm. So when you add that now, 57 and 33, that sound like 90. That's so. And 90 plus 18, that's 102. And then 102 from 180 gives you this what?
So 18, 57, and 33.
Check that again for me.
108.
108. Oh, come just look on and I wonder what going on, you know. So me I get 102. So 108. Alright, and then the 108 from that now would I give you the 72, which is the same thing that Simona Chambers got when she did her measurement over here. So it's just a matter of how you view the thing. There's no one way to get the answer. And for you get the 72 now,
Yes, sir.
you then have to add back the 72 now to 33. So you have to say then, also your reason for this sum would have been what? Angles in a triangle measure 180. Angles in triangle adds to 180. Not true, adds to 180. So that would be your reasoning if that's the route you took. All right. So the angles in the triangle measure 180. Then therefore, we're saying that 180 minus the 72, and as Simara said earlier, if you add back the 33, because this red line right here so is inclusive of the 33, because that angle adds up to this up here. So 72 plus 33, so that's 180 minus 105. And that works out to be 75. And once again, your reason would be the same as hers right down here. Opposite angles in a cyclic quadrilateral adds up to 180. So it just depends on your viewing, how you view it.
Right. Sir, both would work, but I think that the first one that we did probably would be better as it has less numbers to work with, so less likely to lose track.
Yeah. But in the moment, Sam, you're saying that now, because you're under no pressure.
Mm-hmm.
So because you're seeing it for yourself right now, you're saying that no. But you see, in the moment, you see, because immediately you and I both clicked and we said that what you did is what I would do. I never see the blue one. So that was good by Simonia. That was good. All right. So I hope you guys are, like I said, when you're working these questions, we're not doing these classes because we want to work 10, 15 questions. We should be able to do less and achieve more. We should be able to do less and achieve more. So even though I have 14, 15 questions here, if we can work together as a team and work out 3 or 4 of these, and we improve one, our geometric thinking, 2, understand how the theorems are applied, 3, which different methods we can use to get our answer. We can use 5 powerful questions and master 20, 30 questions. We don't need to work 100 questions to understand the concept. I'm not sure if how many persons agree with that. All right. So That's it for that particular question there. All right, so this calculation up here, guys, should have been down here. Okay? Should have been down here. All right. All right, let me see the chat stay now. I want to stay. Amoy, Javari, I want to stay. Danica.
Yes, sir.
Oh, you stay,
Yes,
you stay.
sir.
You're there, but you don't sound like you're there now. Oh, go on.
Everything is
Me understand. Catch on. I try to catch on.
Yeah, man, you try to catch on. But question number 2, man, you're supposed to get back your voice. Miss Gentles, you okay? Kadia,
Yes, sir.
Echo, Trina.
Sir, this a beat my body.
All right, I'm talking to you about why it a beat bad, not true?
Yeah.
All right. Gali, are you okay? Jolene, Sam,
Yes, sir, I'm okay.
Avian.
Catching on, sir.
Catching on. Stacia.
Fine.
All right, good. All right.
That topic here a little easier for me than some of the others. So far, I realize I'm just need to just practice more and more, but I understand this better than some other topics. So let me see.
All right. Everybody got them favorite. Believe me, this was my favorite in high school. Right, this was my favorite. So everybody got like what them like, you know. Let's do another one then, no? And let's see if we can exercise with trigger finger one more time. So moving on to a different one. So that was circuit theorem. We're working on all circuit theorems today. You realize? I'll be a circuit theorem we work on. Do you realize, guys? So when we reach one certain point, we must reach one certain point where we're nice. Okay? So we have a couple. By the time the third one, we're supposed to start here some persons in the chat and the comments, share insights. All right? Okay. So let's do another one. The diagram below, not drawn to scale, shows a circle, which you can clearly see. All right. Want to recognize this thing again?
Yes, sir.
Want to recognize? What does that statement tell us?
There's a cyclic.
There's a cyclic. All right. So what is the cyclic is made by those combination of those letters? P, Q, R, T. Let's look at that. P, Q, R, T. Do you see the cyclic?
Yes,
Do you
sir.
all see the cyclic? All right. So what do you know about a cyclic? No, we just learned about cyclic. You just learned it a while ago.
Opposite angles at 180.
Jolene, we're doing circuit theorem regardless if it's 2025 or 2024. You know? It's the rules them that you have to get used on how you spin them up. So I don't think I'm gonna get. I did the circuit theorem 2025 in one of my previous marathons. I released it on my YouTube channel already. All right. So you just have to do. So all circuit theorem questions are gonna be the same. No matter which year. What you need to catch is the concept of how the rules are applied. So no matter which circuit theorem question you catch, you have to lick it down flat. All right. Yes, Kessin. All right. So sorry, what were you guys saying a while ago? What do you know about a cyclic? What do you remember? We just learned a while ago about a cyclic.
The opposite angles are supplementary.
Good. So we know said this one right here, so right? We know said this one right here, based on what you just learned a while ago, and this one down here, I got add up to what? 180, not true? And then this one over here, and then this one over here, I got add up to what? 180. Please remember that. It's a very trending thing with CXC. Them do this all the time. The points blah, 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 and blah are on the what? Circumference. Now, quick question to you. Is that the only cyclic that you see?
No, sir.
You see another one? Sometimes a 2 there, no? Sometimes a 3 there. So do you see another one? Tell me the letters that make up the other one.
VPQR.
PVRQ
What you say name? VPQRV.
QR.
Okay.
Mm-hmm.
This your talk? Is that what you're talking?
Yes, sir.
All right. So what am I gonna do now? I'm gonna clean up my diagram now. All right. So hold on. Before I clean up my diagram, let us establish. Make sure you visually see it, guys. Do you remember which two angles add up to 180 from this specific diagram that you're looking at now? Can you remember if I erase it?
Yes, sir.
You can remember which two angles add up to 180. All right. Don't lose count now, you know. I got erase the diagram now to look at the other one now. The next cyclic now. Look at this cyclic now. Which two angles add up to 180?
V and Q, P and
V and Q.
R.
All right, and right away, even without looking at what's going on down there, because I know I'm gonna look for the question, I don't know what you're gonna ask me to find. I am analyzing my circle first. So right away, I know this angle right here is 105 degrees. How me
Sir,
get home? Yes, talk to me.
I'm kind of confused right there, so.
Which part?
T wouldn't be 75.
T?
Yeah.
No, we know that's a one different theorem, mama. That's a one different theorem, man. Yes, it would be
But
75.
I'm saying if T is 75, then for me, I wouldn't allow Q to be 105.
Why?
Naturally.
All right. So if T is 75, right?
Mm-hmm.
Isn't Q in front of T?
Yes. So it
So
would be is 180?
yes, because it's cyclic.
Okay. All right.
Good. But the 75 when we get up here, so the 75 up here, that's a different theorem that give you that 75. We're just focusing on the cyclic at the moment. All right.
So the 180 would have minus 105 if you get T.
If you get T, but she got the T a different way. She's using a different theorem to get T. She's using the theorem Buckingham was talking about earlier about angles in the same segment of a circle. That's what she's using to get the 75. But the 75 now is you're getting the 75 from taking 105 from 180 because the angles are opposite.
I had a question about that too, sir.
Sure, go ahead.
Because when I saw it, based on the video I was watching when I caught this, they had referred to it as the Batman theorem.
Yes,
But I was saying that the as PQR would have more to be like two radii, and radii because
Mm-hmm.
no run to
Hey.
two sec two
No radian
two
under the set.
chord. They're two
Right, two
chord.
chord, yeah.
But I was saying, see, because it formed a point at Q, that's why I was wondering if the Batman theorem still applies. So I wanted to ask you that.
The Batman theorem applies with this, you know, and them call it Batman theorem, they call it the butterfly theorem. So the Batman theorem is this. This is the Batman theorem. The Batman theorem states that any you see one Batman symbol. Give me a second here. So the Batman symbol here. That's the Batman theorem, you know. That Batman symbol there. And if I want Batman symbol in a one circle, then the angles at the edge of the Batman symbol, they are equal. So if that's what you're referring to.
Yes, sir. Just wanted to make sure. Because normally when I see it on the papers that they're doing, between P to R would always have a straight chord. It wouldn't have a point Q on it.
Okay. All right. Gucci then. All right. So back to discussing about the second cyclic quadrilateral. So we're establishing that 75 is in front of this angle down here, which is why that angle down here is what? 105. Not true. Which other angle add up to 180 in that green shape? Yeah, Batman and butterfly is the same thing. I call it butterfly because it looks like one butterfly wing, right? But other people, everybody have them own little ways how they help them kissing to help us remember. So if you feel like Batman is easier for you to remember, like if you say Batman, you know, oh, Batman symbol look, use it. I was taught butterfly, but it's not a set thing. It's not set in stone. All right. Yes, Wines. P and R. So this angle again and this one add up to what? 180. All right, good. So now that everything has been, now that you analyze up now, you do your little thing
Sir,
now,
put
right?
in a 75 at you know.
No, we're not finding angle yet, sir. This is just the analysis. When we're ready to put in angle, we put it in. This is just the analysis. Me clean up what my diagrams are. You have to learn to visualize the thing without, right? When you're doing your own thing, you can put your little jottings and stuff in about. We're going to go back to the question now. You see, all of what we just discussed a while ago, Javari, a one sentence give it that, you know? Do you realize all of that analysis is because of one sentence? Mm-hmm. All right. QRS is a straight line. QRS is a straight line. What do you know about angles on a straight line, ladies and gentlemen, folks? What do you know about angles on a straight line? Sorry.
And 180.
I asked you foolishly. Sorry. What do you know about angles at a point on a straight line? Adds up to 180.
The cut and the something that from 90
No.
degrees.
Only about straight line, no chord, nothing.
Oh.
What do you know about angles at a point on a straight line? What do they measure?
180.
Good. That's the answer more here. So therefore, that's 60 there, and whatever this be, and whatever this be, those three angles right there should add up to 180. All right? So just remember that now. This is the analysis. This thing here is what gave us that information. The Foxy them say QRS is a straight line. You see this now? These are what we call helping information. So they might help with. They gave us the 75 and the 60 to help us to find what they're about to ask us to find. All right, you ready now? All right, let me clean up my diagram. Let me see if my brain are working now. Determine the value of each of the following angles. Determine the value of each of the following angles. You must do what? Show detailed working where necessary, and you have to what? Give a reason to support whatever answer you come up with. The reason what they talk about is the geometric reason, cyclic, quadrilateral, angles in a straight line, measure 180, Batman angle, all that's what you're referring to as reasoning. All right. PTR. Hold on. PTR. Danica, that's your question. You came up with that answer. What is PTR?
75.
And how you get the 70? What was the reasoning behind that 75?
The butterfly angle.
I know, so your name.
Yeah,
And if you get the proper theorem for it. So 75.
I don't remember the name.
You cannot say Batman theorem is.
We can't put butterfly theorem and
No, not the name, so. We only say that. Or you're going now say, all right then. All right. How long you be? You're coming back at like half an hour or so? All right. You'll probably soon come back. All right. So Danica, you cannot say butterfly theorem. You're not going to get away with that. Where supplementary come from, Javari? Oh, you're using a different theorem? No, but remember, say Javari, 75 up here, so it's not because it's supplementary. Right? If you're gonna take that route, you see, you're gonna have to tell us that this angle down here is 105 first. And then you say supplementary, if that's the route you want to take. No problem. If you ever use the word supplementary, you have to tell me what this angle is first down here. And then after you tell me what that angle is, then you say it's supplementary to that. Now, Danica is saying that the angle is immediately 75. And she's correct. But what's the reason for that? Who knows what the reason for that is?
Sir, is it the thing that said something about angle subtended by... I don't remember. Something...
Who is ZU? Somebody just text and
And
said
there
ZU.
is no chord. There you would have to create a chord.
Right? You'd have to, but we can do that. We are allowed to do that. So we can create a chord right here if we want to.
Is it into the segment theorem?
Correct. Correct. The segment theorem. Danica, it is the theorem that says angles in the same segment of a circle are equal. Spend some time, because you can recognize it, but you're not remembering the statements. So you are correct. So this one says that what? Segment theorem. Remember,
Excuse me, sir.
Yes.
When you're putting down your reasoning for your answer, can you just put down the segment theorem, or do you have to explain it down?
No. Segment theorem, because there's only one segment theorem. And every marker know what the segment theorem is. The segment theorem states that what? The angles that are in the same segment of a circle are equal. There is no other theorem that relates to the segment. So if I use the segment theorem, you're going on a road.
Okay, sir. Thank you.
Okay. All right, good. Danica, you're good with that now? So, Kessin and everybody else, Batman theorem is called the segment theorem. Good. Remember, people, Batman theorem. For those who don't know what the Batman theorem is, the Batman theorem is this thing right here, where the lines create like a Batman symbol. So enter your spot any form of Batman symbol. Just know that the angles at the edge of the Batman wing or the Batman symbol, they are equal. And the correct mathematical reasoning for that is that segment theorem. Or if you want to show so you're bright and you're bad like me, you can say angles in the same segment of a circle subtended by the same chord or arc are equal. Lovely. Good. So Javar, your way is just as effective, you know. It's just that with your way, you end up finding out something when we never ask if you find. It's like you're basically with your method, you're finding two angles in the same question.
Even get the answer, sir.
All right, so no limitations from where I do. Once you get your answer, you're good to go. All right, so put in the 75 here. Danica, you finally get rid of that now?
Yes, sir.
Moving next one now. Angle TPQ. 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 Let me just use this because I realize also that students have a challenge in knowing where the position of the angle is. TPQ. You see with the angle form? Right, that's so. That's a big problem for a lot of students, you know. If they listen, you say if you don't know where the angle is, you're going to use a wrong theorem to find the angle. So your ability to locate the correct position of the angle is key. Because you may know the theorems like how anybody else know it. But if you don't know where the position of the angle is, you'll use a wrong theorem to find the wrong angle. Or fine, we may never ask if you find. All right, so let me see what the chat is saying now. The one in the middle. Oh, you're telling me. Oh, yeah. Right. You're correct. One in the middle. All right. So this angle now, ladies and gentlemen, folks, this angle right here now. Suggestions. How do we find that one?
Sir, you could find, so angles on a straight line add up to 180. So you could subtract the 60.
Go ahead, I'm listening.
You could subtract the 60 from the 180 and you get 120.
All of that?
And then, yes, sir.
Mm-hmm.
And then the angles, so opposite angles are supplementary.
Okay, brilliant. Very good. Excellent. So, her suggestion is this. All right? We can learn from each other, people. We can learn from each other. So she's suggesting then that since we have already established that this angle right here, since we have already established from the analysis part of the question that this angle right here and this one right here adds up to 180, we established that from the onset. She's suggesting that we find this angle right here. Both of these together, this one and this one together. So we could start off by saying simply that angle, give it a name, TRQ, angle TRQ is equal to 180 minus 60, which is equal to 120. What's the reason for doing that? The reason for doing that is that angles at a point on a straight line sums to 180. All right, that's the reason to support your answer.
Sir,
Therefore, yes, question.
where you get the 60?
Oh, it's on the diagram there.
Sir,
Oh,
who gave this working out a while ago?
I'm sorry? Oh,
Who is the one who suggested this way?
Simonia Chambers.
Simona, thank you. Because seriously, this is the way how I was looking at it.
Yeah.
Using what you had drawn earlier to show that on either side it would have been 90. What I initially did was looking at the 60 and where the straight line is, I subtracted the 60 from the 90 and got 30, and then added 30 to the next 90 on the other side, and that's how I got the answer.
But that is a big error, because you're assuming that this line meets the, and this is not a tangent, you know, that's a secant. And there's no rule that says if a chord meets a secant, it's 90. You're assuming that this is 90, and that is not true.
Right.
So that's a big, big error. And you gotta get a proper D for reasoning.
Is there a get the answer or but the way how it work? Just book up so I'm gonna get it.
Yeah, book up so I get it. If it's not consistent, it now go get the marks. So all right, so now that we have that now. Oops, what's going on? Boy, why me I delete? What is going on? I keep pressing stuff. Okay. All right, so adds up to 180. Keep pressing stuff. All right. Give me a second, guys. My hand keep pressing stuff. Adds up to 180 degrees. All right, so now that we get the 120 there and we have the reasoning, therefore the conclusion now is that angle TPQ is equal to 180 minus 120, which again is 60. And therefore, the reason for that would have been what? Opposite angles of a cyclic quadrilateral. I should say the right thing. Hold on. Yeah. Opposite angles of a cyclic quadrilateral are supplementary. All right, so that would be the reason. Now, pay close attention, guys, and tell me what do you. All right, so basically this angle is what? 60 degrees, not sure. But what do you notice about this? Look at that 60. Isn't it kind of giving you something like it I said? Then, sir, we couldn't just. What is your mind telling you at the moment? Look at the 60 where we just find. And look on the rigmarole you go through if you get that 60. But look at the 60 sitting on the outside here. Do you think that they have a relationship, or you think are backups?
No, sir, it have a relationship.
Yes.
The angle. Yeah.
If you check theorem number 6 or theorem number 7 in your books, is a theorem that says that the exterior angle. Somebody confirm it, please. Check your theorem notes, please.
Yes, sir.
I gave you it. Oh, this one also me give it to you. What does it say, Mr.
Yes, sir. You gave it to us.
Tell me what it say.
I was just looking at it.
Tell the class what it says.
It said the exterior angle of the cyclic quadrilateral is equal to the interior opposite.
Okay, so let me identify that for you then. Look at this now. Let me show you the cyclic now. So now we have the cyclic here. Boop. See the cyclic here. And if you notice that I extended one side of the cyclic. So by me extending one side of the cyclic, right, it has an exterior angle. And there's a rule that you could use to get your answer directly, because the angle that is on the exterior of the cyclic quadrilateral is exactly equal to the angle that is opposing its interior, right here. So if you knew the theorem, you could have jumped from that in one line and get the answer. But guess what, people? We're not the exam. We're not thinking about that. Miss Chambers immediately saw her method. So if she take the long route to get to the answer, that's her route. You're not subjected to using this route. It's just that this route shows you, it shows up a lot more about the fact that you know about circle theorem. But 6 of 1 half does not the same thing. 6 of 1 half does not the same thing. You got your answer. Okay? So just want to put that out there. All right, let us clean up the diagram now. So let's see what I'll go on. So let's put back Danika's angle that she had up here. 75. And let's put back the angle that we have here, which is Chambers' angle, 120. And she also put the 60 right here. So those are the angles that's the route that we took to get to our answer. All right, moving right along. Obtuse angle. We know that an obtuse angle measures what? An obtuse angle measures what? I want to say to me, what does an obtuse angle measure?
More than 90, but less than 180.
Okay, greater than all right. Greater than 90. So all right. So the angle that they're referring to, let me say obtuse angle POR. They're trying to say that the angle at POR, it is greater than 90, but it is less than 180. Where O is the center, so they want you to find the angle what? Right here at O, PO what? So hold on. POR, where O is the center of the circle. But I don't see no O. So that means that we have to assume that here says O. Because the only two part that connect P and R is these two lines right here. Only them two lines are connecting. P under something there connect us to R. So based on what they're saying, we have to assume, we have to make a geometrical assumption that this position right here is O. So what would be the size of that angle? Talk to me now. This more here.
It would be 75 times 2. It's 2 times the angle and the circle.
Hey, father. Yes, you are correct. Oh my God. You are correct. The angle at the center of the circle is twice the angle that is at the circumference. So you see, even though, you see the trick with this, is that because there is no chord here, a lot of you guys might not see it. But you can also create a chord, people. You can create a chord. That chord will not affect any of the angle. So yes, Ms. Jenkins, you're correct. It is the central angle theorem. So the angle they want down here is going to say that angle POR is equal to 75 times 2. And because people like Samara cannot remember the theorem, you have to help her by writing stuff like central angle.
I remember all of them. You don't do that.
Yeah, man, we just want to dry out your shell, man. All right, that is it, ladies and gentlemen, for that particular question. How are we feeling about circle theorem now after 2? Are you guys starting to see what is required to at least pick up 1 4 or 1 5 out of the 6 or 7?
Yes, sir.
Or not yet? So funny, I don't see your mouth, I see your eyes. Oh, is that echo? Echo, you just pick up something, you're picking up something? Simona says 20%. No, you Echo still a ball, alright. So hopefully you stop ball. Alright, so Kyle say not yet. Alright, cool. That means say. So Kyle say not yet. Am I the only one that genuinely enjoy doing these? Yeah. Me and you alone. Me alone, Simona. Me alone. Alright. Let's see what I go on now. Kyle say.
Well, I think it's just to do these things, it's just you have to actually know the rules and stuff. Because there's a lot of rules, that's what I realized from listening to you.
Yeah.
And I think that's the only issue the problem that I'm having.
Once you're familiar with the rules, and the only way you can become familiar with the rules is like you have to be doing a lot of these questions. I did at least 150 of these questions when I was in high school. I did them till suddenly my stomach was sick. I did them so much that I started dreaming and seeing them. I did them so much that as me see the diagram, I saw the answer. That's how much I did them. I did a lot of them. My teacher would drill me with them. Safani says no comment. Alright, Daniela says looks manageable. Zahina says you get it or you're getting it. Which one?
Sir, getting it. I'm getting there.
Okay. I need Kessing says I need to read over the different terms and rules. Right? Which is you have to just familiarize yourself with. Remember, people, if this is your question that you're going to be doing, if this is going to either be the question that you're going to prioritize, or it's going to be one of those questions where you're going to steal the marks to throw in your bag, you need to at least be familiar with 5 or 6 of the theorems. Not all 9, but yeah. So I think they want to just a small amount of questions. I did them until I was sick. I did every question in the textbook that was at high school. You have a video on the topic? Of course I do. Everything I teach, I have a video on it. Alright, so let me see who is saying. Alright, so Latisha not remember the names of the theorems. Okay. I'm glad not have a voice, no opinion, so we can give no ideas. No, but yeah, remember, if it's something that was taught in class and you left it on the back burner, it's going to feel new. So yes, Simonia, I have videos on this. The thumbnail on my channel will tell you. So you can go watch theorems 1 to 3 and look at the examples, and then theorems 4 to 7. Alright. So where's I going now? See now. Jalia say I like doing them, but not 100 yet. That's fine. I think it's because I already made up my mind that I'm not. Yeah, that's possible. That's possible too. Alright, I'm picking up little by little. That's good. Alright. Love this. Okay, good. Remember now, you say once you start love this, you have to love bearings. You have to love sine and cosine rule. Alright, let's move on. Let us see if we can convert some more people now. I need some more guinea pigs now. Sorry, me not listen now. I need some more persons to fall in love with this topic. Let's go. Let us see if we can spot something more now. Come again. The circle shown below. 3 questions now we're doing now. And what are you seeing, ladies and gentle folks? Tell me what you see. Without me even have to talk. What have you seen?
Cyclic.
How you know say a cyclic? What sentence in this instruction tells say it's cyclic?
The circle shown below as center O and the points A, B, and C, D line on the circumference.
So 3 back-to-back question. And are the same sentence. What does that mean, people? Julene, in the meantime, could you do me a favor? Could you check on the 2025 circle theorem question on your device right now and tell me if you spot that sentence and let me know in the chat? To type in CXC Math Tutor, click on the 2025 past paper, scroll down to question 10 and tell me if you see that sentence. Moving on. Well, Julina, check that for me. All right, it says a straight line. What do you guys know about a straight line?
180.
All right, so right away now, the straight line, what am I talking about? This straight line right here, so maybe I don't know if it's going to be needed, but what we know is that angles in a straight line measure 180, so we don't know what that is. All right, ready? So it passes through the point E and B, and then give us some helping angles here. All right, so this question here doesn't give us a lot. So this is the kind of question now. It doesn't give us the only thing it gave us right here is that there's a cyclic. So now this is where you have to help yourself. Let us identify the cyclic, by the way. So the cyclic is this thing right here. Even though it's not fully cyclic, we can basically create it. Right? We can create it if we want. So that we can eventually figure out if something is opposite to something. We don't know yet, you know. But we just know that there is a cyclic, a similar one cyclic nearby. All right? Good. Lovely. Do you see a center? Do you see a center? And how do you... Sir, no, sir, it's not on it. All right, so that means they never come. Okay. So you see a center, right? If you see a center, there's one of two or both things that you need to look for. If there's a center, you need to look for two things. One start with R, one start with D.
Radius and diameter.
Good. So there's a diameter here. And you see one center, people. You see? Look for one diameter. If you don't see a diameter, you're probably going to see radius or you're going to see radii. Sorry, Lord of mercy. This class has been recording about radii. Is that you're going to see radius or you're going to see radii? All right. Now, big question. We're going to jump into some rules now. Now, the diameter does something at the circumference. Does anybody recall? What does the diameter do at the circumference?
It creates a 90-degree angle.
Very good, very good. So right yes or no, Javari, because of the Thales theorem. Sir, what? Thales theorem? Yes, theorem number 5. Mr. Pierre taught it to you. Check in your class. Boom. That angle up there is 90. I know the reason why that angle is 90 is a theorem called Thales theorem. Sir, I'm not going to remember Mr. Thales. I'm not going to spell it right. I'm not going to remember that his name is Thales. Is there any other way? Yes, you can write out the whole thing. Write down the Thales theorem for me, please. The Thales theorem says that the angle made by the diameter of the circumference, guys, write that down. The angle subtends, the angle that is subtended by the diameter of the circumference, the angle that is subtended at the circumference by the diameter equals 90 degrees. Equals 90 degrees. So you see the angle that is my point on? We can confirm with 100% certainty that that angle is 90 degrees. Look out for these things next week, Tuesday. Keep your eyes peeled for the Botman theorem, the Thales theorem. Keep your eyes open for isosceles triangle. Keep your eyes open for cyclic quadrilaterals. Those things are CSEC little pawns. I hate them send out come. Those are the little theorems or the little things that they send out come to war, you know? And because no arm up, they beat nobody. All right. That orange looking triangle now. What kind of triangle is that orange looking triangle?
Scalene.
What you say to me now?
Isosceles.
Oh.
Sorry, my bad.
My bad, you should bite your tongue to say that. Sure. So that angle right here is 37 degrees. Do you agree? And why do you agree? Me just tell us at 37. Why do you agree?
The radii of the same circle are equal.
Pardon me, say that again.
Radii of the same circle are equal.
Very good, because them two sides here equal, it means that them two angles here equal. All right? I see what gave us that?
So, sir,
yes.
Wouldn't that be the same for the other triangle?
For the other triangle up here, this one?
Yeah.
But those are chords, those are not radii.
Oh, okay.
And there's no rule that says chords of the same circle are equal. So at the present moment, you have a isosceles triangle and you have a right angle triangle in the same circle. All right? Guys, I love questions, you know. I love when time students interrogate me, you know, and challenge me, you know. So ask me questions. Okay? All right, good. So we have some information now. We have something can work with, right? Help me now. Write down the mathematical names of the straight line BC and OA. What is the name of the straight line BC? BC is called a what?
Chord.
Correct. BC is called a chord. Very good. What is the line OA called?
Radius.
Radius.
Very good. Very good. Very good. I'm not seeing some persons in the chat. I don't mean some bright people in the class. They don't really like talking and them like keep quiet. Like Kenzani Joseph. She doesn't talk a lot. But no say she a bad of a thing. Echo, how you stay now? Any confidence? Any 10% improvement in confidence?
5%.
Huh?
5%.
Blow. Hopefully by the end of the class you reach 120.
Yes.
See, so you've never been taught this topic before?
No, sir. The teacher, there's a lot of things that you're teaching. There is a phrase I'm actually hearing because him not them something.
Oh, okay. Kyle, where you say now? Still no confidence. Why? Why is there no confidence? What is happening? What's the issue? Have you never learned this topic before? That's the only way there can be no confidence at all. Have you never learned the topic before? Is the first you've seen it? All right. Good. So people, you're struggling with this, you have a video on my channel. You can go in your personal time and space if you know that you're going to. Don't run away from it, run into it. All right? So don't study the theorems. Oh, your fault that, Kyle. Not my fault that, man. Think it's my fault, Think it's me, I make it hard. All right, moving on. Determine the value of each of the following angles and you must show detailed working where necessary and give a reason to support your answer. So we're looking to find the angle that is at X. Somebody help me out. I need to know how do I get to find the angle at X? What are the steps that lead me to that?
37 times 2 and subtract it from 180.
All right, but how me get it first? 37. You have to tell me how me get that first. So angle, hold on. Give me a second, don't move. Angle A, B, O equals, we said it was 37. What was the reason for saying that was 37?
Sine isosceles. Radii.
Right. I don't want you to say if you say isosceles, you'll get away with it, But Geneva gone with the answer already. All right, and Shamir gone with the answer already. Girls, no, hold on. Wait for me, the girls. Hold on. Take time with me. So 37 degrees, right? The reason for that is that the radii of the same circle are equal. That's the reason. Not true? All right. So before we get at 37 now, continue now. You were saying that therefore angle X is equal to, tell me what you just tell me a while ago. Say it again.
Oh, 180 minus 37 times 2.
That's 180 minus what? 74. That's all?
Yeah.
That's 106. What's the reason for that?
Angles in a triangle are supplementary.
Very good. Angles in a triangle are supplementary. So persons who are learning this for the first time or me teach it to you, but you never quite grasp it. You have to be open-minded in this class, right? You have to be open-minded and take down some stuff, some little notes and stuff, right? Things that you just learn for the first time, jot it down. All right, good. All right, so therefore, we're done then. That's X, right? So we're done. So we give one reason that led us to finding X. Good. Boom. Angle Y now. Angle Y. Angle Y.
We got 90 degrees because the
Theta, nobody hurt yourself. See that?
Thales theorem, yeah.
Right. So hold on, take time with me now. Wait. That angle up there is what? BCD?
Yes.
So angle BCD is equal to 90 degrees because of the Thales theorem, you said?
Yes, sir.
All right, Thales theorem. Therefore, what now? Angle Y equals?
180 minus 90 plus 49.
All right, 180 minus 90 plus 49. So that's 180 minus 139, which is equal to what? 41 degrees. What's the reason for that?
Supplementary angles.
Very good. Our angles in a triangle measure 180. Any one of them, supplementary angles. Supplementary angles. Lovely. Wonderful. All right, everybody catching on? Kylo, you stay with that one there.
So can you go back on the diagram?
There it is. Kylo, you stay with that one there now. Echo, how is that one for you?
Not bad, sir. Not bad.
Right, so that means you sound like you catch them two little theorems and now. You're starting to see them. Now, is there another way that we could get, is there another way that we could, there's not another way. All right, Danica, I want to put you on alert for this one. Because you realize that it almost look like something there. One Batman theorem. Because I know someone in there I think I want Batman theorem. We don't want to talk. Because you probably say, okay, say me connect that to that. I want Batman theorem. Nope. This line slightly bend, you know. Hope you know that line slightly bend. So it's not dead straight. C is not directly straight from O. So it's slightly bend. And because it's slightly bend, you notice that the angle is a little bit bigger. It's a little bit bigger than 37. So be careful. Don't assume stuff. And don't draw things on the diagram just to suit your need. Sir, BA is a secant or a segment. BA is a line. BA is a secant. Alright, so BA is a secant, but the region right here, Geneva, is a segment. So you're right and you're right and you're wrong. Because you said BA is a line, so that's a secant. But if you said the region under BA, then that's a segment. Alright, so that is it for that one. Alright, so that one they're not too bad, people. Remember, guys, I cut off the bearings. I didn't want this class to be too convoluted. I don't want to do too much things one time. I'd prefer to do a whole entire marathon on what you call it, sine and cosine rule. But I'm not sure if I'm going to have enough time to do that. Because I'm going to be doing statistics tomorrow. By the way, I should let you guys vote. Hold on. Because I might end up doing something that I don't need to do. So I'm going to put it out there for tomorrow, our final free marathon, right? And then I'll give you guys a break on Friday. So we can reminisce and cool off a little bit because you've been at this for 4 days straight. Do you guys want tomorrow for us to do a whole entire series of questions on statistics? Listen to the options, people. And you're going to vote in the chat. Here are the options. Do you want to do... No, Julie, remember say me tired too, remember say me a human being. And I have a life as well. All right. Do you want me to do a complete series on... Do you want me to do a complete series on statistics, measurement, which means area, volume, and all them something there? Or do you want me to do a complete series on sine, cosine, and trig ratios and them something there? What is it that you prefer?
Trig.
Hey, chat, in the chat, type it in. I want to see the votes coming in. Votes. No, Shamir, we can't do both. Not in the same day. I have to focus on one. I don't want to mix up on the brain. All right, let me run the chat now. All right, so I'm seeing. You're going to leave soon, Simone? All right, Simone. All right, so first option. I don't remember the first option being a Graham. You have 10 with first. So trig, bearings, massa. Second, echo, I don't know what is it. I don't remember what is the second option. I just list them out. Statistics.
Based on how you look like I trigger.
I say it look.
Yeah, man.
I see both. I see option 3. I see trig. All right. I see Ajanaya say trig. Hansen, you can't get both. You can't have the best of both worlds. Jalia saying statistics. Javaria saying measurement. People, and you can't do this to me. We don't have much time. Listen, on the topics, listen, I want to do the one that challenges you the most. The one will lick your physics every single time. Statistics is not as difficult. It's doable. But I want to attack the part of the question that challenges you guys the most. And based on what me seen in the chat, is giving trig. Because remember say trig come in 2 parts, you know. Trig comes in section 2, you know. But it also comes at question 3 as well. Or question 4. So remember, so you have 2 types of trig. You have the cosine and the sine rule. Trig value is 12. Statistics value 10. But stats are something one can manage. Trig. Those trig, yes, trig come with bearings, yeah. All right, so the consensus based on the group, I wasn't taught bearings, so I don't understand it. All right, so the consensus then tomorrow is going to be trig. I say, here what I'm going to do. To satisfy everybody, because we can't please everybody, I'm going to come with 4 bearings and trig question tomorrow. I'm going to come with 3 stats question, and I'm going to come with 3 trig question. 6. Deal? So everybody get a taste. All right, deal. Right? Because we can't satisfy everybody, right? I don't see anybody talking about the other one, measurement. So instead of, because I like the class to be focused on one area. Now. I just want to attack it, like I'm focused on pure circle theorem tonight. That's what I wanted these marathons to be. But I'm gonna do three stats tomorrow. And I'm gonna make sure there are 3 different stats. I'm gonna do one cumulative frequency. I'm gonna do 1 histogram. And I'm gonna do I'm gonna do 2 cumulative frequency. But I'm gonna do 1 backwards and 1 forward, and then we do 1 histogram. That should cover it. All right. And then now in the Saturday marathon, right? I'm hoping that everybody here comes. Although it's been all you have to pay for it. I hope you guys come. For the Saturday marathon, I'm gonna do a pie chart. So that should take care of stats. So 3 stats tomorrow, 1 pie chart Saturday, right? So that should take care of stats. And then tomorrow now we do 3 trig question. We're gonna attack 1 Saturday. That's a 4 trig question. And then now on Sunday now we just wrap it off with the January 2026 past paper. So everybody good? Kissing at the same price as the marathon. Same price. Yes, go ahead.
We trigger wrapping all of them there, but which day you have to do the measurement? You know, I have no idea where you can squeeze the computer measurement into.
The thing is that remember you're gonna get 2 measurement questions, 1 Saturday and 1 Sunday, you know.
Okay.
So those are the only 2 measurements that I can do for you. All right, and then that will be it. Yeah. Yeah. Question.
You're gonna go for the regular time for tomorrow, seeing that you're gonna cover so many topics?
Yeah, 6 to 9. I'll go 6 to 10.
All right.
Yeah, man. I said there's 3 each now. Remember tonight we do at least 1. How much question we do already? These 3 of this. We do 2 more of this, and what time is it? 8:05. 2 more of this and we're alright. Or 3 more of this and we're good. So if you have a video on measurement, just send it. I only have a class on that, Jalia. Not Jalia, sorry. Jalia that? Ellis, me only have a class on that. Only a class on it I have.
Send it.
Oh, you still send it? All right. Text me for it, please.
Okay.
All right. Back to this now. So everybody good then? 3 stats tomorrow. 3 trig and bearings question. Me already have the plan what I'm gonna do. And then Saturday now, so me just do 1 more stats and then 1 more trig. So we have 4 trig, 4 stats, so we're good. And then now Sunday we just wrap it up and deal with the 2026 past paper. All right, so we're good. 2005 guessing for the Saturday marathon or the Sunday one, anyone. All right, let's go. All right, so how much more of this are we all right now? 3 more? Have we got 3 more? We now 3 more now, nobody?
No, sir.
Yes.
All right, probably squeeze 3 more. In the diagram below, A, B, C, D are points on the circle. Hold on, did we finish this one? Okay, we did on it. All right, trigonometry. In the diagram below, A, B, C, D are points on the circumference of a circle. Javar, you catch that again? You see what I'm going?
Yes, sir.
Wanna see
So
what
which
I'm
paper
people?
is this?
This should be 2014. I not quite remember. I just cut up some questions, so I can't confirm. All right, guys, you see what I'm going? 4. Yes, Geneva, you see one Z angle. All
We
right.
see arrow now.
You see arrow now. So
We are way up on how long?
That you wait for how long? The Z angle. All right, good. So ready now. So in the diagram below, A, B, C, D are points on the circumference. People will see that sentence 4 times in a row now. 4 back to back. Hear them and do it. Can you now confirm that this thing is viral? This thing is trending. That make you know say there's something here. And if we finish it like that, it'll go form one cyclic. I don't know if the cyclic might be using, but usually when there's a cyclic, there is, yes, Geneva, there's a segment theorem too. Understand Batman theorem here? Anybody see any Batman theorem?
No connect.
Yes, sir.
No, do you see the Batman symbol, sir?
You see, but in a connect.
Batman theorem no connect, sir. Batman symbol no connect, sir. That's the Batman theorem. Not true.
So what can from a different angle, that's why.
All right, good. Well, tap the funny from the angle then. So what can we ask? So question then, Danica, question to you. What can you say about the angle 2P?
Sir.
Huh?
I'm confused. Can go back up at the previous diagram?
With the Batman theorem?
Yeah.
Okay.
No, not that one. The one before the one we're doing now.
This one?
Yeah.
Yeah.
Sir, but you were saying that y could equal to 37.
Yeah, because this thing wasn't there. This was not there. I mean, put it there. I'm just saying it's not straight. The line away when we just erase. If you try to connect O to C to create a Batman theorem, it's incorrect. We never created nothing here. The Batman theorem was already there automatically. We never create anything.
Okay.
All right, good. So question now, people. Back to the class now. What can we say? Sorry. All right, so what can we say about angle? What can we say about angle 2P and angle Q? What can we say about both of those angles? What's the conclusion of those 2 angles based on the Batman theorem?
They're equal.
Good. So you say later on when that come up, no matter tell me say no with the answer be now, you just tell me say 2P and Q equal. All right, cool. All right. Somebody mentioned, Geneva, was it you that mentioned something about some Z or something like that? Okay, good. How do you know it's Z? Javari, how you know it's a Z? What gives it away?
The arrow, sir.
The arrow. So we can safely say that this thing right here, so, is a Z because of the what? Arrow, not true? And what you know about Z angle?
The 2 corner them.
Equal.
Yeah.
So if this angle down here so is Q, what is this angle up here?
Q.
Q2, not true? And remember say, this angle, and this angle, them equal. So that means that all three of them angles, they measure the same. Reasoning that. All right, cool. Do you guys, let me clean up my diagram again.
So,
Do you
sir,
guys, yes, question.
if those three angles are equal, that means that ABO are going to form the semicircle.
ABO. This is a semicircle there, but not ABO. So one semicircle, yes. Semicircle is right here.
We look that side.
But she say ABO. That's one triangle.
Right. Yeah.
Okay. All right, good. All right, do you guys see any Taylor's theorem? Remember, I said Taylor's theorem is picked up whenever there is so it would be two chords. Yeah, but we're not a chord theorem, Daniela. Anybody see any Taylor's theorem?
Yes, sir.
You see the Taylor's theorem? Tell me the letters that meet the Taylor's theorem.
B, C, and D.
B, C, and D. So you're saying to me then that B, C, all the way down to D forms a Taylor's theorem, right? Because of the diameter.
Yes.
The question to you now. What can we say about 3P and R? What can we say about those two angles? Them equal to what?
90 when added.
Equal to 90 when added. Now, true. Now, see what I want? People in the chat, do you see that we are applying the rules? If you are still confused, it is simply because you have never been taught this topic before, or you make up your mind, so you hate the topic like pies, now you just don't want to learn it. That are the only two reasons that prevent you from getting this. Because we do 4 questions so far, and we've been using the same theorems again and again and again and again. All right, boom. So now that we analyze it, yes, question.
Sir,
yeah.
Isn't it the same for A, B, C?
A, B, C. Yes, of course. This angle up here is 90, of course. Very good. So this angle up here is 90. Excellent. So if that angle is 90, what can I say about this angle, and this one? What can I say about those three?
Isosceles.
No, because them two here, Jabari is not a radius. What can I say about those three angles?
They
add to
add up
180.
to 180. They're supplementary.
Good. So we can say correct Shamira, correct Shamir, correct Jalia. So we can say later on we might need to add 2p to 3p to 90 and equate it to what? 180. We might need to do that. Not true. But we don't know yet because I know me not read the question. Everything that we have done so far has what is called an analysis of the circle. You first need to analyze the circle and see the things that are there. And when you analyze the circle, you can spot your little 90, you spot your little angle in a straight line, you spot your little isosceles triangle, you look for your little arrow, you look for your little Bachman theorem. Those little things, spot them first. And watch magic happen right before your very eyes. State the reason why angle ABC is 90. Jalia, you just said that, you just asked me. You just tell me, say ABC is 90, So now they're asking you to tell them why it's 90.
Because the Thales theorem.
Right, funny. You're not going to get away with that. Give me the correct reasoning.
The angle subtended by the diameter is 90 degrees.
Perfecto. We don't want nothing more than that. So the reason why angle ABC is 90, as Jalia says, is simply because what? The angle subtended by the diameter. The angle subtended by the diameter equals 90 degrees. That's the reason. Now, should any one of you guys go on the exam and for whatever reason you remember Taylor's theorem, you write it down, you're still going to get the marks same way. But you see, because them say state the reason, Tails, who has your microphone unmuted? I'm talking about this already. Guys, please control your microphones. Stevenson, on your microphone, right? Because it's unmuted. Stevenson, your microphone, that? Because you're unmuted, you know. All right, cool. All right, so that's the reason. So if you remember, says Taylor's theorem, I don't think they're going to, in fact, I think they'll give you props if you write that down. I can't tell you that. But anyway, moving on. Determine the value of each of the following angles, and you must show detailed working out where necessary, whilst giving a reason or reasons to support your answer. Angle BAC. BAC. This angle right here. What is BAC? Need the reasons that led to the answer, you know?
2p plus 3p.
Remember, I said, Jolly, I said this is 19, you know? So use her answer that she just got now and help yourself.
2p plus 3p plus 90.
Correct, sir. Equals what?
180.
All right.
Carry over the 90.
No. Yeah, add up, right. In that sense, yeah. So add up the 2p and the 3p now.
That'll be 5p.
5p
equals
talk to me.
180
minus
90.
So 5p equals what? 90? 5p equals what? 90?
Yeah.
So p
I got
equals
divided
what?
by 5.
Which is equal to what?
18.
So divide by 5, so p is equal to 18. Not true? Is that your answer?
Yeah.
No. Somebody correct him, please. Yes, you're working out is right, you know, but that's not your answer.
Add the 18. No, multiply 2 by 18.
So 2p is equal to 36. Remember,
Yes.
Jabbar, them never say you must find p, sir. Them say you must find the angle what? BAC. And the angle there, BAC, is 2p. So that's why the angle is not 18, the angle is 36. Wanna get that? Or the chat stay? Kyle, you stay?
So when I get the 18, if you multiply by 2?
What is the angle that is at 2 BAC, sir? What angle is at BAC?
2p.
So if you get p is 18 and a 2p you want to find, you have to multiply p by 2, sir.
Oh, yeah.
Yeah. Geneva, I have one good pen, you know. I make you buy me one, you know. You need to buy me one stylus pen. You have to comment that up, but we must write it good. I can't write no better than that. My pen is going. And I done my pen. Hold on there, wait. Did Simara leave the class? Hold on there. Give me a minute there, guys. Hold on. Come back in the class, please, and thank you very much. All right, let's go. So I hunt my students, them, you know. Anyone on the left the class? I'm a final saying I left the class. Me a hunt them down. Okay. Oh, what was the reason, by the way? You're not giving me the reason I know. You're doing the working out. You're going to get 1 mark. What's the reason? How you know so if you add 2p and 3p and 90 and make it equal to 180?
Supplementary angles.
Give me something else. More something more than that. You keep and leave out something.
Isosceles.
Take out the isosceles and just say the other thing.
Angles in a triangle.
Thank you very much. So combine it now. Angles. Sorry, not angles in a triangle. The sum. Johnny, you're still right, you know. You just because you keep leaving out the triangle. Me start to get frustrated now. All right, so this oh God. Oh my gosh. This child. All right, so the sum of the angles in a triangle are supplementary. Good. Angle Q. Oh, Echo, you stay. Kyle, one there. A lot of people them with negative against the circle theorem. On stay.
Sir, Amy doesn't understand.
Amy has not been coming to class.
Amy said she's bad with geometry.
Amy has not been coming to class. Ellis, you okay? Amoy?
Yes, sir, I'm okay.
Oh, good. Abigail? I know the people them are alright now, like Katie, I know say you're alright, you know. And certain people, Golly, I know so no good. Certain people know
Yes,
so.
sir.
Avi, I know you stay. You tell me earlier you were catching on. What go on?
Yes, sir, I'm okay.
You're okay, or are you becoming more okay?
I'm okay.
Okay, good. Kissing actually I go on. Kaya? Kaya? You okay?
It's a mute. Yes, sir. Yes, sir. Yes, sir. We're good. We're good. We're good.
Lovely, lovely, lovely. All right, good. Angle Q. So check for some more people. Angle Q. Angle Q there. Oh, down here, sir. Tanika. What is that angle?
Sir.
Mm-hmm.
A 36.
Yes. Why?
Some angles that me not remember.
I gave you the theorem earlier and I told Danica never to forget it again.
The Batman theorem.
I don't know Batman theorem, but what is the theorem?
Second theorem.
Oh, Batman theorem. The Batman lick. All right, so it is the segment theorem. Good, that's it. Done. All right. Echo, yes or no? You said something earlier. You said catching on better than when you just start. Let me see. I'm catching on a bit. All right, good. That means progress I make.
Can I see the diagram one more time, please?
Yeah. Progress is being made. So this angle right here, so you say is 36 from the first calculation Javari did. And because of the angles being in the Batman theorem or segment theorem or what you want to call it, then this angle is also 36 as well. All right.
Okay, thank you.
All right, good. That's it? Done.
I want next Z if you check it out, but the arrow just go that the way there.
I want Z, but they not in a relationship.
Yeah.
But when I find R, remember say them cut off R by accident. I cut off R by accident, guys. Look. Me find Q, me find P, me find Q, but me not find R. Talk to me now, me go find R now.
2P plus R.
2P plus R.
Sir.
2P? You sure it's a 2P this?
I'm sorry, 3P plus R equal 90.
Yeah. That's what she said earlier. Remember that, Javari? One time we said that this thing is 90 because of the Taylor's theorem.
I remember that, sir.
All right, that's what I meant. When we had discussed the analysis. Yes, I was saying, Mr. Pierre.
That's me, sir.
Yes.
I'm gonna for the next half an hour.
You're gone? All right. Yo, big up yourself.
Yeah. All right. I might come back on next half an hour.
Okay. We're gonna have half an hour left by the time you come back. All right, let's go. Right. Ready, guys? Ready. So we're saying that the angle right here is 3P plus R. So remember, when you go through the analysis, Javari, especially if this is the approach, well, not if this, I'm a teacher, so you're supposed to do this approach. when you make the analysis, you need to jot them down and remember them. Don't just say it. As soon as you see something, jot it down to the side. Okay? So right now we're saying that because of the Thales theorem, 3p plus r equals what? 90. But because we did already find p to be what? 18. I'm going to say 2p at 36, but p at 18. So that is 3 times 18 plus r. That's equal to 90. That's 54 plus r equals, yeah, 90. So r equals 90, take away 54. R equals, what is now? 36?
26.
Yeah, but then why we never just said, Lord Jesus of mercy. Wanna see what I say?
It's an isosceles.
Oh my God, Shamir. We can never just tell me that. I'm just run around circle.
Me never see it either.
When I not see the isosceles people, my God.
Oh gosh.
That was just so much work a while ago just to find R. But anyway, we find it. Big deal. Right? I feel like if we just rub out all of this and just write R equals 36. Bomb, really have the same circles are equal. I don't feel, Guys, now if you help me looking, man. Me must say I'm alone, I can't see everything, I'll see a lot of things, but I can't see everything. So now if you look to see if one other way did it. That's a fun job. Alright, done that. Boom. How we feeling? Secretarium bad? And I hate it still?
No, sir.
Okay.
I'm definitely more optimistic now.
Simona Scott, hello. Leave out of my chat, boy, you hate. Listen, Simona, I'm going to beat it, but you hate it. A joke. You like what you like, my friend. Ashani says she alright. Ellie says she good. Simara, if you ever left the class, you see? When we find them out. Alright, know yourself. You're not leaving the class, miss. With a passion. Okay, so you're supposed to slap this too. Okay, alright. Definitely more optimistic now. Good. Ellis. Simona, why you make him frighten me? I see a cyclic. Oh, Jennifer just excited. We got the next question. Nah, do pan my paper. Alright, Alicia, let us move on. We're not going to entertain the girls tonight. Not tonight. Let's go. Alright, the diagram below shows a circle.
Come here.
Simone, your microphone is unmuted, I think. Alright, the diagram below shows a circle. Javar, you see what I go on again? You think I mean select them question up on purpose? Tell me what you see. Jav, tell me what you see. Javar, not there.
So I'm trying to tell it.
You're tired of telling me, not sure?
Sir, me see card.
No. I'm talking about the sentence. What does this sentence tell you?
It tells us that it creates a cyclic quad where a 4 points line on the circumference.
A four time we say it today. 4 times we say it today. And because of this, I want to notice, guys, you realize that every time there's a cyclic, there seems to be the Batman something. You realize? Every time we book up on one cyclic.
Yeah, blend.
Jabari, microphone. Do you realize, guys, that every time we find one cyclic, yeah, Geneva, there's a segment as well. So do you realize that every time we find one cyclic, there always seems to be that Batman something over here, so? And you realize every time we see that something there, that Batman something there? Yeah.
So I say every time it's still like that, I have one Batman something there.
Hey, don't say what me never say. I said, do you notice that so far, every time we spot a cyclic, we spot a Batman something, I did not say conclusively that that's going to be the case. So don't try to set me up, Daniela.
All right, then.
Okay. All right, good. So talk to me now. We are analyzing the diagram now, RP is a diameter. When there's a diameter, the man named T, where him come from, where him name? Smart me, I go war in a little girl. Alright, come in now. When there's a diameter, him always forward up. Tails. Tails always forward up. Once you see one diameter, look for tails. Until you see one diameter, look for tails. So look now. Tails, I go create 190 down here, so. Not true? Do you agree?
Yes, sir.
So therefore, we can easily find the top piece right as so. How do we find that top piece?
90 minus 54.
Good. So let's jot it to the side here. 90 minus 54. And then this angle is what? 36. Not true? All right. Drop it in here, so. Right? Do you realize, guys, do you realize that I am analyzing my diagram and I know me not look on the question where them ask me? Do you see the approach I take to answering these questions? I need to know what I'm dealing with before me go find out what them ask me about it. You have to investigate who you are dealing with first. And then, whatever question is asked, you can answer. I look at circle theorem like this, people. This is how I look at circle theorem. First, you have to know somebody before somebody can question you about it. How can I ask you questions about a circle and triangles if you don't know what you're looking at? That's how me look on it. That's how my teacher taught me. Come tell you, my teacher a legend, you know. My teacher a legend.
Wish I could say the same.
All right, moving right along, Jalia. Moving right along.
Right.
Moving right along. All right, let's go. All right. What else we see now? Tell me what else we see now, man. We not see nothing else.
I see
segment.
3x plus 2x. I see the so you have a tangent and then you have a diameter running straight through, so you could take that as a radius, and the angle 3x and 2x would add up to 90.
Okay, so you're saying that 2x right here and the 3x is 90.
Mm-hmm.
Excellent, good. Buckingham, what you say? Well, you see what? You see something now, like Buckingham?
Sir, Mr. Card.
All of the card. Me I talk about the theorem then.
Sir, I was saying that there's a segment.
Oh, right, that's so. So angle Y and angle Z what? Equal, not true?
Yes, sir. Yeah.
When I ask you guys, what do you see? Don't tell me you see one radius and one chord. That doesn't help us. You have to tell me, say, sir, I see two angle equal. Sir, I see one Z angle. Sir, I see one triangle. Sir, I see one 90 degree. That's what I mean. Don't say you see chord. That not help no way.
Sir.
Okay,
Yeah.
sir.
Would the 3x on the outside this so would it could we use the theorem with this the cyclic quadrilateral something?
But the thing is that there is no actual cyclic there, you know. There could be if we connect R to Q.
Okay.
So when I said earlier that statement usually hints, when you see that statement, look for a cyclic. That doesn't mean it has to be there, but look for it. All right, so look for it. There's something else, man. Let me see there's someone. All right, yeah. Since I was nothing gonna have enough information, let us toggle along then. Come.
No, wait.
Oh,
So
okay.
what happened to the one that went outside right there? Will you use that? The 3x that went outside the circle, yeah.
Yeah, man. Simonia used it earlier. She said that the 2x and the 3x adds up to 90.
Sir, and the AP line.
AP line. AP. Oh,
AB.
yeah. She said 2x plus 3x Buckingham adds up to 90. She said that.
No. So they break up so many body here.
But all the points at P would equal.
Huh?
All the points at P would sums up to 180.
No. They won't all be because we're missing the piece down here, so. But she said 2x and 3x adds up to 90. Remember that RP, you know. RP is a diameter and it comes straight down to meet the tangent. So that's why she said it was 90. Get it, Danica?
Yes,
Danzi?
sir.
Okay, good. All right, so now that we have enough information, we can move on now. Determine the values of each of the following angles, show detailed working where possible, and give reasons for your answer. Angle X. So the only place where angle X, we can use what Simone said earlier. When she said that RP meets the tangent PA at 90. So we could say that, come Simone, since it was your suggestion, tell me what I would write down for the calculation.
So the point at which a radius meets a tangent is 90 degrees. Therefore, 3x plus 2x is equal to 90.
2x. Hold on, give me a second right now. Yes, hold on. So 2x plus 3x. Hold on, give me a sec. No, why is this dragging? Hold on, give me a sec. Okay. All right, so you said 2x plus 3x equals 90. And that's 5x equals 90. So x equals 90 divided by 5. X equals 18. What's your reason, you say? Radius meet tangent?
Yes, sir.
What was the radius? Radius what? What's the name of the radius that you're referring
OP.
to? So radius OP is perpendicular to tangent what?
Sir, you can go.
Yeah.
RA.
RA. No, tangent.
RPA. RPA.
And a R, a B.
Oh, B.
A BPA.
Sir.
Oi.
You could try like 180 equals 54 minus x.
180 minus 54.
No, 180 equals 54 minus x, and that carry over that and subtract 54
Hold on.
from 180.
180 minus 54. I'm assuming that you're subtracting the 54 from the fact that these three angles add up to 180. Is that what you're saying? That's where you get the 180 from?
No, I've seen the angles. A triangle equals up to 180, right?
Right, that's what I'm asking you. Are you saying that it's these three angles that add up to 180? That's what you're referring to?
Not all three, just the one with 54 and x.
No. Angles in a triangle measure 180, sorry.
All angles are going to measure 180.
All angles inside the triangle measure 180. So this 54 plus whatever that be adds up to 180, sir. So the method that we are about to try, that's a suicide bomb. All right, sir?
Yes, sir.
Good. All right, so.
Sir, Deviana said 3 times 3x would be 54.
3x would be 54. Oh, but are we finding x? No, they never say must find x in Geneva. So we already find x. X is 18. Oh, but you're suggesting that this angle would be 54? Okay. Okay, all right, cool. She says she know. All right, why now? So how would we find why now? Why they now? Why they up here, so?
Sir, why they up?
Yes, so what would you do to find why now? Talk to me.
Sir, we use RP, line RP.
Mm-hmm.
And use the 50 minus 54 there. So the 1 second. You can't fit it.
The 36. The 36.
Yes, sir.
But you have to tell me how we get the 36. Remember that analysis code that they said we have to reason it out down here. So start with that now.
Sir, angle
RS.
Q, angle RS.
Angle RSQ.
RSQ will be equal to 36.
No, how you get the 36?
Sir, the 36 will be fall on line QS, which is 54, minus the
90.
90.
That's how you get 36. But what's the reason for that?
Sir, it's something they say. What do you call it?
T.
Tails.
Tails theorem.
Yeah.
So you have to, remember, you can't just write down an angle and just put some stuff on people. You're not give them the reason how you get a 36. So you just say that. Tails theorem. All right. So now you get a 36. Now what you're saying now?
Sir, we use the 54, sir, and then would we so add it to the 54, then you take it away from the 180, that's all? Or it's the other way around?
Yeah. So you add the 54 to what? Sorry. So, which is 90, right? And then add it to what?
The one, no.
So this and this you say is 90, right? Cool.
Yeah.
Mm-hmm.
You would add it to 180, or I take it away from the 180?
Yeah, but you take it away from 180, but something you have two unknown angles here.
Sir, Q and P?
No, you have the two unknown angles here, the Y and the X down here.
Oh, sir, we just find X look a while.
Ah, so X are 18.
Yeah.
All right. But you never needed, listen, you see the 54 and the 36 was not needed enough. Because remember, working on, we already have 90. So you finding the 36 right here is a pointless operation.
Okay.
You have to work too hard. You don't need, because if you find 36 and then add it back to 54, you're saying it's 90. Why not just say 90 already? So you could just simply say, right? Because you're fishing out the right answer where you're talking too much. In terms of you're mathematically talking too much. So what you should say is angle Y is equal to angle Y. Come on. Angle Y is equal to 180, which is for the triangle, right? Minus the 90, which is for the Thales theorem, not true?
Yes,
plus
sir.
the 18 for the X, so you just have the 18 that you control up here. So when you add that, now you're gonna get 180 minus 108, which is 72 degrees. And you drop two theorems now. You'd say one of the theorems is that what? It's Thales theorem, which supports the what? The 90.
90.
And then you'd say angles in a triangle measure what?
180.
And that's how you get your answer.
Okay. So we never have to go through all of the struggles.
Yeah. It's just excessive. It's just excessive mathematical calculation. We get your tongue twisted and tie up your hands and confuse you. So you have to find the most effective route to get to your answer. Okay, so that's it.
Okay, sir.
What's another term for the Thales theorem?
The angle subtended by the diameter equals 90 degrees.
Okay.
The angle subtended at the center, the angle subtended at the circumference by the diameter equals 90. It's just that mentioning tails, it shows a lot of depth about who you are when it comes to geometry. Because not every student know the Thales theorem. Very few, from less than 10% of students know the Thales theorem.
Okay.
All right, good. But there's one more. We don't find Z yet. Hold on. So we'll find Z now. How we find Z, guys?
Isn't Z
Z is Y.
Oh, talk to me. Danica?
Z are Y.
Z is Y. Correct. Very good. Very good. Z, that's the most effective way. And can some, alright, so Danica don't answer. Why did she say Z is Y?
Segment.
Segment what?
The line the same arc in the same segment.
That seems something we just say, right? Right, that seems something, right. So Danica, yeah, so Z, so you can say Z is equal to Y, which we know that Y is equal to what? Sorry, Y is equal to what? We just find Y a while ago, 72. So Z equal Y and Y equal 72. And the reason for that is segment theorem. Are we done? All right. All right, good. Now, guys, one more, them two here, and then you can take the rest for yourself. I'm leaving two for you to go and practice along with any other ones on you can buck up on. All right. So I'm doing this last one here for you, and then you guys can have fun. I don't think you don't need me anymore with the amount of theorems that you have discussed on how to go around the triangle. Zane? And it's supposed to alright, you know. And you can survive.
Sir,
Yeah.
Are you sure you're going to send it in a group?
Send what?
No, it last two.
Lord God, I know me not to send the document them. I
Exactly.
posted them on YouTube.
Sir, every time we ask, I will be sending it this evening in the group. Don't worry.
Oh my God. Buckingham, you can't take time with me, you know, sir?
Sir, what I say, you said you can't say, you know, so I'm busy, so me now get this any. But you promise us so faithfully.
Listen, the heart and the body is willing. The mind is willing, but the body weak. The body weak.
Excuses, excuses, excuses.
I come in for the 5th time in a row. W, X, and U, O. And I 4 of them this time, so no cyclic that did it. W, X, and U are points on the circumference. Javari, I don't want when next week come and you go spot this, you know, your brain only pick up yourself. And pick up, say, it have to say 4 points for it to be a cyclic. Me just want alert you from now.
So, sir, so this is another segment.
I mean another segment.
No, the Batman thing me attack.
It does not have it. You have it.
Better with that one there.
Oh,
Sir,
I know
that kind of look like one semicircle.
Kinda.
Sir, can I? It is a semicircle.
Right, so it's a kinda.
Sir.
All right, ready. So W, X, and U are points on the circumference. Correct, Shamir. We can see you. All right. So W, X, and U are points on the circumference. TV is a tangent. TV is a tangent to the circle at U. So TV, hold on, let me grab something. TV is a tangent to the circle at U. All right. So what that mean now? When you have a so question, what is WU called? What is WU called?
The diameter.
And it's meeting the tangent. So when a diameter meets a tangent, what forms?
Right angle triangle.
90 degree. Buckingham or whoever your mic is unmuted, you talk about your personal business, you know. And I'm not editing the video. So right here says 90, not true? All right. Anybody see any Tails theorem? Shamir, you see the Tails theorem?
Sir, could you repeat that? Sir, so I'm Buckingham decide.
Yes, sir.
Hold on. Shamir say yes. Somebody ask a question. Someone repeat what?
I was just no, I didn't say anything.
Okay. Somebody's asking to repeat something.
I am saying if you could repeat what you just said about the tangent and whatever.
Oh yeah. When a diameter meets a tangent, it forms a 90-degree angle. When the diameter, which is this thing right here, entire one diameter meet one tangent, the angle at which they meet is 90.
Sir.
Yeah.
X is 90.
I'm not ready for X yet. Me analyze my diagram. Please leave me alone, Jalia.
Sir, did not analyze video.
I'm not reach that yet. All right. So when the diameter meets the tangent, I'm at 90. All right. Do you see the Tails theorem? Anybody see the Tails theorem?
Yes, sir.
Yeah. Geneva, I'm so come to you. Give me a second there. So the angle of here is 90, right? Everybody agree with that? That's 90?
Yes, sir.
Yes, sir.
Good. All right. Cool. Somebody said them see one isosceles triangle. Geneva, how do you know it's an isosceles triangle? What makes you say that?
The lines.
Strokes.
Strokes, right? So this thing here and this thing is equal. That means that this entire shape right here, so is an isosceles right angle triangle. What did sorry, Jesus, me give it away. Oh gosh. I was about to ask you what is this shape called, you know. What is that shape called? Specifically.
A right angle triangle?
Be more specific.
An isosceles.
Be more specific. Combine the two of them.
An isosceles and
right angle triangle, sir.
Combine the both of them here.
Right isosceles.
And isosceles means
Right. Where's the right?
triangle.
Where's the right? Isosceles. I haven't heard this in my life yet. A week. Oh God. It is called an isosceles right angle triangle. If I never jolly say something like that. Only she alone would say something like that. Oh, okay. All right, guys. Now going good. All right, let's go. All right, anyways, we have here looking funny now. All right, boom. So ready now. We analyze and we don't know. Use the appropriate theorems. State 3 reasons that explains why the measure of angle Z is 45. So you them know it's 45, but you have to tell them 3 reasons why it's 45. Hey. Why?
All right, sir.
Sir,
One at a time, one at a time, one at a time. Danica, go first.
sir, divide 90 by 2.
Divide 90 by 2. What's the reason why you divide it by 2? What makes it?
The Thales theorem.
Thales theorem.
Mm-hmm.
No,
it's not that. Sorry. Where the W and the U makes the right angle triangle and you divide the 90 by 2.
But why you divide it by 2?
Mm-hmm.
Because it's an isosceles. So both of
Oh, God. No, I'm not like that. I'm not explaining properly.
Sir.
You have to explain why Z is 45, you know.
Okay, watch out.
All right.
So X is 90, right?
X is 90, yeah.
Angles in a triangle are supplementary. So if
right.
and this triangle specifically is an isosceles,
All
meaning
right.
2 of its sides are equal.
All right.
If you have one side already, then you're gonna need the other 2. And to find the other 2, you subtract the 90 from 180, where you get 90. Then you divide that by 2. You split it in half because both sides are equal. So both sides are 45. And if down here, so this little piece before you reach Z, this so is 45, and this entire angle is 90, then Z can only be 45.
Dalia, do you correct, Dalia? Do you realize that nobody's seeing your hands on the screen? Man, you must be a computer screen. All right, correct. Okay, all right, guys. All right, she sound like a boss, right? She sound like a boss. All right, very good, very good. Let me help you out, please. Let me help you out. Oh my God. So, oh my God. All right, Dalia, you're perfectly correct. So you're gonna say angle Z is 45 degrees because WXU is an isosceles. So so that's 45 degrees because this red triangle here is isosceles, and then we can say that base angles are equal. Base angles are equal. So therefore the angle down here, which is 45, the angle down here, which is 45, come so it's a 90 now. It's a 90. So these two have to be 90 divided by 2, which is 45. So therefore now the angle Z is going to be 90 minus 45, which is equal to 45 degrees. Anyways, I feel like there's something simpler than this here. So one of the reasons, write down the reasons, guys. That was just me talking a lot. Write down the correct reasoning. Angle Z is 45. Angle Z is 45 because angle Z is 45 because one, diameter is perpendicular to tangent. Diameter WU is perpendicular to tangent UV. Diameter WU is perpendicular to tangent UV. And WXU is isosceles. and WXU is isosceles. And by writing that, the examiner will know that because it's isosceles, you have to split the angle in a halfway. So that's why the 90 will be divided by 2. So that is enough. That's enough to give the examiner evidence that you know what you're talking about. Secondly, angle Z is 45. Angle Z is 45. Angle Z is 45. Because it's 45. Since the angle between the tangent and the chord, since the angle between the tangent and the chord, since the angle between the tangent and the chord, angle between the tangent and the chord is equal to the angle, is equal to the angle, is equal to the angle at the circumference. The first reason I gave you, I think it has two things in one. I think it has two reasons in one. So that would be 3. The first one I gave you, I think it had 2 in 1. I think I'm kind of merging with my reasoning. And the last one is the third one. That's it. But I guess you see when you ask it, pardon me?
Could I have said it's equal to the angle in opposite segment?
Yes, you could say that. So angle between the tangent and the chord is equal to the angle that is in the opposite segment. All right, so however we write it, as long as the examiner understands that you understand, then I think you're going to get the marks. All right, last one, guys. The diagram below shows a circle with diameter KF. See if you can spot it. Diameter KF, where that there? Boom. Where there's a diameter, what do we find? Start with T.
Mr. Tails.
Mr. Tails coming to play. Where's Mr. Tails? Where you find him? At which letter?
FHK.
At where?
FHK.
FHK. Right, that's what you say?
Yes, sir.
So right away, me know so me can find a little piece here when we're ready. How would I find that little piece when I'm ready?
Angle subtended by the diameter equal 90.
Yeah, we don't establish that. So I say, how would I find this little piece up here when
Take
we're ready?
away 19 from 90.
From 90. All right, good. When we're ready, me deal with that. All right, cool. Continue. So this one sentence here, the diameter shows KF. That okay, good. Line. Yes. Question. I'm not hearing you. Sorry, I'm not hearing you.
Oh, never mind.
Okay. All right. Line EFG is a tangent. Let's spot that. Line EFG is a tangent. All right. So where there's a tangent and you have a diameter, what's going to happen?
90 degrees.
On both sides. Yes, sir. And this, sir. At a 90. All right. Cool. Just want to know, as you read, no amount of nerves in an exam can prevent you from doing opposite from what we've been learning all night. You know, every question I analyze my circle. I don't look at the question. I really don't care about the question. I only care about the question when I understand what I'm looking at. So no nerves. You don't need to try to remember anything. Analyze the diagram first. See, remember, listen, guys, there are things that you need to look out for when you see circle theorem. Look for triangles, angles that adds up in a triangle measure 180. Look for angles that are point in a straight line. Look for diameter meeting tangent. Look for radii of the same circle. Look for the Bachmann thing. Look for Z angles. Certain things you have to look for to give you the comfort you need to answer the question. So that would be the same alternate theorem. Alternate theorem. I don't know that theorem there. Maybe I refer to something. Are you referring to Z angles? Simone, are you referring to Z angles?
Maybe a Z angle she refer to.
Because she said alternate segment. alternate segment. Oh, yeah. No. What she's referring to is this one. Adisha talk Jabari. Hear so? I hear so. Okay, she's saying that this is equal. That's what she's saying.
Batman.
Oh, yeah.
Yeah, Kessin, there's no Z angle here because we don't see no arrow. But I think Simone is referring to the 56 and X. I think that's what she's referring to. All right, so EFG is tangent to the circle at F. All right, we have that. The points FH, K, and J. Remember this? Chances are these are what? A cyclic, but we don't really see the full cyclic. So cyclic now have a role here. The reason why the cyclic doesn't exist because we don't connect this to this yet. And there's usually no reason for us to connect them. If there was reason to connect them, they would have connected it for us. All right, good. So go see what I want to know. So we have everything I know. Ready? By showing each step in your work, we are appropriate. Find the value for each of the following angles. Angle X. All right. That means we're ready for you now, Simonia. Or Danica. You guys always pick up that theorem. Angle X is what?
Okay.
Simora, what do you say?
56.
What's the reason?
Segment
theorem.
Segment theorem. Let us get used to it. Segment theorem. Remember, don't rely on my video alone. Don't rely on my question. Go and fish for your own questions. Holy Papa was January and May. Yes, Shamir.
What about angles subtended by the same chord?
I see him theorem, it's just that when I say segment theorem, it's just a shorter way of preventing students from having to remember all those words. So you're correct. Angles subtended by the same chord are equal. But just to prevent them, because them always are complaints and can't remember some of stuff. So I find something unique to help them.
Okay.
So that's good. All right, so we move on to the next one now. Oh, we're done. Box cover. We're done.
So that's a no hit. Then can do that one.
No, sir.
I hate.
Something
Yeah,
else. You left off something.
Hello, me say I hate that. Remember.
Anyway, sir, why the angle at the center is twice the angle at the circumference?
Oh, Lord Jesus have mercy. Sorry. I didn't see the angle Y. Sorry. Okay, all right, angle Y. All right, come, angle Jalia, come. Angle Y is equal to what?
256 times 2.
Which is equal to?
I don't know, sir. That one.
Oh, God. I'm worried for you.
120.
How will you say? 56 times 2 is 120. Buckingham.
112. Come on.
No, 2 6 12. No, 2 carry the one.
Yes. Right. People do not let Buckingham teach in the maths here. and the answer is what? Central. Sorry, the reason is what? Central angle theorem. Are we done? Ladies and gentlefolks, we have done a lot. I've shown you how to think. I'm not going to show you the answer. I'm showing you how to think. I'm showing you how to reason. Go and fish for your own questions. Fish for your own questions. Find past papers. Fish for your own questions. And use this video to guide you. And if you're completely obliterated by the topic, as if you don't know what the topic is about, find the video on my channel. All right?
And you will be sending us the paper, guys.
All right, I will be. All right, ladies and gentlemen, it's 9 o'clock.
Before you come out, say no.
All right, guys. Have yourselves a productive, peaceful, and wonderful night. Thank you all for the
Sir, now do the next one.
No. The next one is for you.
Sir, do it now, sir.
No, good night. Have yourselves a good night. Pick up yourself. I'll see you guys tomorrow.
Thursday, Mara, say one more.
Have a good night.
Sir, come on.
Good night, everybody. Good night.
Sir, one one you look complex. Come on.
Good night.
One more. Sir, I did the 9:30.
Love Max too much,
Come
man.
on.
Good night, man.